Hello and welcome to the Aero Systems 3 Flight Sim Analysis video. For this we had 5 pilots, and for these 5 pilots we will be measuring them on 3 different categories and be marking them down in this table. For the first category we are using pitch. So here we have a bar graph generated in MATLAB. As you can see, all 5 pilots are on it. Now this graph shows the length of flight in seconds. You can tell from this Tala took the longest with 353 seconds, or 5 minutes and 53 seconds, and Yusuf was the quickest with 284 seconds, or 4 minutes and 44 seconds, making Yusuf the best at this category. Now let me show you how this was generated in MATLAB. As you can see here, we have a script. This script is split into 3 sections. The first section is defining the data into variables and is creating the final time. The second section is defining who is who in the data and who had the best time. And then the last part is creating the bar graph, which you saw at the start. When we run the script, it will complete those sections and will give us the bar graph and tell us who was the best with the shortest flight. Now we can enter the time into the graph from earlier.
For the second category, we have pitching moment. Pitching moment is the amount of torque applied to the wings. This means the closer to zero, the better, as it means the flight was smoother without harsh movements that apply moment to the aircraft. We have generated a graph from MATLAB. This shows the movements that is generated by each pilot. The graph goes into the negatives as it can apply in both directions. You can tell it was a close first for Nick being the closest to zero and Tahal being last with the most amounts being 1.49. To generate it, we wrote another script in MATLAB, and just like the last, it is split into 3 sections. The first section, we are assigning data to variables and turning it into an array, then into a matrix. In the second section, it is finding who had the smallest pitching moment and then is printing that in the command box along with the other pilot's final pitching moment. And then the last section is creating the graph so we can see the data easily. Now we've got the final results for this category, we can add this to the table.
The final category is rate of change in altitude. Initially on the data, you can see it says altitude versus time. In this section here, we're just kind of describing what is the input. So we're trying to find the rate of change with altitude. So we're basically just having the inputs there. Looking down, you'll be able to see a small section called index, where we are defining the area that we're going to be looking at the data with. So we want to find the height at 400 feet. Initially, the data was written where it'd be taken at 50 feet, as that is usually the best time to gather data. But as certain pilots took off and landed, it had to be changed to 400 feet to get a overall better result. Altitude versus time, we used the data from the index functions and we compared them with each other. We were able to then plot out the data with each pilot. So when looking at the graph, you can see who came in for the smoothest landing. Altitude versus time, we're plotting out how the altitudes with every single plane was taken in the graph. You can see how all the pilots came in for their approach. When looking at the data, you can see that Nick, Yusuf, and Ruben had a smooth landing compared to Usman and Tal's landing, as it was a much smoother approach in and had a very small rate of change. With the rate of change, there were 5 subplots made, where you'll be able to actually compare the rate of change each individually. When looking at the data, we are able to tell who had the smoothest landing approach into landing. As you can see, with pilots such as Ruben, he came in for a smooth landing, but at the last moment took off and landed again, destroying the landing gear. When looking at Usman's data, you can tell that it's had incredible rates of change to around -45 to +45 in the span of a few seconds, likely telling us that he crashed the plane. But when comparing the data from Usman and Nick, it had a similar approach landing in, with a hard landing on both occasions. When looking at the data, we can tell that Nick had a smoother landing over Youssef, mainly as the rate of change was smaller, meaning that Nick was overall better with the rate of change and performance. Yeah. Now looking at the data, we can see that Nick won 2 categories, making him the best pilot.